Nice, so we've got the notes for composition of functions. So we've dealt with the arithmetic operations before, addition, subtraction, multiplication, division. So addition and subtraction of functions are just like terms. Multiplication, that's your FOILing, your distributing. Division, that's either long or synthetic polynomial division. However, there is an additional operation you can perform on functions that cannot be performed on numbers. That's referred to as composing. So numbers can't be composed with each other, only functions. The composition of our composing involves in using one function as the input for another. So essentially you're chaining equations together. Plug a number into one equation, take the answer to that, plug it into the next, and you actually keep doing this for as long as you would like. So f of x takes some input value x, so any number, returns an output value, which is called f of x, usually our y value. When you're composing functions, the output of one function becomes the input of the next. So for example, if f of x is x plus 4 and g of x is x squared, f of g of 2 would mean plug the 2 into the g of x equation, so 2 squared, and then evaluate and plug that value into the f of x equation, so 4 plus 4 is 8. So f of g of 2 would equal 8. Plug 2 into g, 2 squared is 4, plug that number into f, 4 plus 4 is 8. You can pause function with input is known, which is what we did up here, or treat the entire g of x as your input. The result will be an equation. So there's actually kind of two notations, f of g of x with the parentheses nested, or this open circle is the operator symbol for composition, like the plus sign for additions, division for division, so on and so forth. In either case, you work either from the inside out or right to left. So, all right. So if we look at the first ones here, given the values of f of x and g of x, find the indicated. So f of g of -3 means plug -3 into the g equation. So essentially find a g of -3. -3 squared plus -3 plus 2. So that's 9 minus 3 plus 2. So that's 6, that's 8. And then that is plugged into f. So f of 8 is -2 times 8 plus 8. -16 plus 8, or -8 would be your final answer. All right, so look at number 2 here. F -2 goes into f, so we're finding f of -2. So -4 times -2 minus 5. 8 minus 5 would be 3. And then that into g. So g of 3, 2 times 3 squared, plus 3 plus 3. So on this step, please remember exponents come first. So that's 3 squared, 9 times 2, which is 18, not 2 times 3, 6 squared, which would be 36. So that's 18 plus 6, so that would be 24 is my final answer. So -8 into g, so g of -8 would be -8 minus 7, so 8 minus 7, or 1. And then into f of 1. 3 times 1 squared minus 3 times 1 minus 8. So 1 squared is 1 times 3 is 3, not 3 times 1 squared, or 9. Minus 3 minus 8, so that would just be -8. And for our last one, 4 into g. So g of 4, 2 times 4 squared minus 2 times 4 plus 14. So that would be 32 minus 8 plus 14. So that's 24 plus 14 would be 38. So then we need f of 38. So -3 times 38 plus 11. That one I'm not going to do in my head. So -3 times 38 plus 11. Well, -3 times 38. So that's -114 plus 11, which comes out to be -103 all in. Times, let's check my work over on the left first, because that seems awfully large, -8. No, 38, okay. So down here at the bottom, we got composition where we don't have an input, so it's still just x. Now it still kind of works the same way, so f or x gets plugged into f, but we already have that. That's just f of x, so x squared plus 6x minus 10. And then that goes into g. So what that means is that any x's in g become this equation. So g of f of x means take all of that in for that x. So 3 times x squared plus 6x minus 10 plus 2. Distribute 3x squared plus 18x minus 30 plus 2. and then combine like terms. 3x squared plus 18x minus 28 would be your answer. Okay. So 2 here. So x goes into f, so same thing before. F of x is 2x minus 2. So g of f of x means take this into any x's in g. So actually that's twice here and here. So 2x minus 2 squared minus 3 times 2x minus 2 minus 15. This would also be a good place to get in the habit of putting parentheses around your substitutions. Now this is a FOIL. 2x minus 2 squared is 2x minus 2 times 2x minus 2. I'm going to do the FOIL in my head. It's going to be 4x squared. Shortcut is then multiply together and double, so that's negative 4x doubled will be negative 8x. Negative 2 squared is 4. Distribute the 3. Negative 6x plus 6 minus 15. And then collect your like terms. So 4x squared minus 14x. We got 10 and minus 5. Be your solution. All right, last one. X into g. Well, g, so g of x is just 3x minus 6, the original g equation, and that into f. So that replaces both of those x's. So f of g of x is 3x minus 6 squared plus 3x minus 6 minus 13. So that's going to be 9x squared, so multiply together, be negative 18 and then double, so negative 36x in the middle plus 36. All right, I mean negative 18 twice 18, yep. And then over here, those parentheses don't really matter because there's nothing to distribute, so they can just go away. And then combine like terms, so 9x squared minus 33x. 36 minus 6 would be 30, minus 13 would be 17. So that would be my final composite function. Now, one we didn't kind of do an example of is that if there happened to be a coefficient in front of this squared thing, you work the FOIL out first and then you distribute, because just like with numbers, exponents come before multiplication. So if there had been a 2 out front here, I'd work out this 9x squared minus 36 plus 36 and then multiply everything by 2 to distribute the 2 that was out front. But that brings us into the section.